Good afternoon, dear students. Yes. So, today we are going to start with another chapter of PUC first year, okay, chemistry, that is classification of elements and its periodicity. Okay. So I hope you might have gone through the synopsis. So yesterday again, I have, synopsis have been sent in your groups. So respective lesson, okay, you have to just download it and then you can read it to the PDF, right? I hope you have gone through the synopsis which was sent yesterday, right? Okay. So based on that synopsis, okay, we are going to solve some multiple choice questions, okay, from like the important concept of this chapter. So let us start. So first question, Newland could classify elements only up to. So there was a scientist called Newland. Okay, he discovered certain elements. Okay, so which like till which atomic number or till which element did he classify the elements? Yes, do you know it? Till which element was the classification made by Newland, the scientist Newland? Yes. What is the answer, students? You can use the chat box for answering. Yes. Newland. Newland gave his law of octaves. Okay. So he gave a law which was called as law of octaves. Okay. So what he did, he arranged the elements in their up to eighth element. So what he could see that the first element and the eighth element would resemble. Okay. So it could resemble the same features or same properties. Okay. So he related this to the notes of music. Okay. So the notes of music. Okay. Vedpati has answered. She has answered it as C. What about others? Others don't know the answers. Yes, Newland was a scientist, and what he did, he classified the element, okay, first 30 elements, and he did it up to, yes, calcium. Calcium is the correct answer. Okay, fine. So let us go for the next one. The statement that is not correct for the periodic classification of element is the statement that is not correct for the periodic classification of elements is A. The properties of elements are the periodic function of the atomic number. B. Non-metallic elements are lesser in number than metallic elements. C. The first ionization energies of elements along a period do not atomic number. D. For transition elements, the d subshells are increase in atomic number. Yes, how will you answer this? Which statement is not correct for the periodic classification of elements? Yes. So which of the following statement is not correct about the periodic classification of elements? So when we see the first statement, that is the properties of the elements are the periodic functions of the atomic number. So this is true. Okay, so this is a correct statement. So option A is correct statement. So let us see the next statement. non-metallic elements are lesser in number than metallic elements. Yes. Okay, so when you see the periodic table, so to your left you have some non-metals, and in between you have the metalloids. So when you compare the metals and the non-metals, so non-metals are lesser in number as compared to the metallic elements. So this is also a correct statement. So we are checking which is not a proper statement, which is not a correct statement. Then when you compare the ionization energies, okay, ionization energies of the elements when you go along the period. So this is the period, okay, when you move from left to right, that is termed as a period. And when you go from top to bottom, there it is called as what? It is called as groups. Okay, so the first So the first ionization energies of elements, when you go along the period, what it will not vary in regular manner, but it will vary with increase in atomic number. So as you go across the period, what will happen? The ionization energy goes on increases. So this is also a correct statement. Now the last statement, for transition elements, the d subshells are filled with electrons monotonically with increase in atomic number. Okay, so eventually the electrons can fill in s orbitals also and d orbitals also. Option D. Okay, option D is the uh, option D. Okay, option D is the not a correct statement. Okay, let us go for the next one. Noble gases were included in Mendeleev's periodic table. In which group? So when we see the Mendeleev's periodic table, so Mendeleev's periodic table, it was given before the modern periodic table. So if you see the Mendeleev's periodic table, so noble gases were placed separately. Okay, so where it was placed? Yes, where it was placed? Okay, Tasmia has answered it as D. Vedvati has also answered it as D. So when you see the noble gases, okay, so if you have first year textbook, you can, Vamshi Krishna has also answered it as D. So noble gases, if you see your first year textbook, you can see that the noble gases were placed in zeroth group. Okay, it was placed in which group? Zeroth group. Okay, so zero group. So first is there, seventh is there, eighth is there, none of it. So option number D is the correct because it was placed in the zeroth group. Okay, fine. Let's go for the next one. Consider the following changes. A, giving you A plus electron. So it is the first ionization energy, and A plus, okay, plus A plus, when you remove the electron from this, it will be A2 plus electron. Okay, so this is the second ionization energy. Okay, so the energy which is required to pull out the two electrons are E1 and E2. So E1 and E2 are what? These are the energy which is required by to remove the two electrons. Okay, they are E1 and E2. So what will be the correct relationship between these two energy? Okay, so we know that what is ionization energy? First of all, ionization energy, it is the minimum energy which is required. Okay, to remove an electron from an isolated gaseous atom. Okay, so when you want to remove the first electron from an isolated gaseous atom, so the energy required may be 1300 kilojoules per mole. Okay, suppose then when you want to remove the second ionization energy electron, so the time the ionization energy will be much more. Why? Because the nucleus, what it will do? when you are removing the electron from the outermost shell, okay, one electron you have removed. So this nucleus, the protons, what it will do, it will hold the outermost electrons more tightly, right? So when you remove the first electron, then what it will do, it will hold the other electrons more tightly. So as a result, the energy which is required, the minimum energy which is required to remove, it will be more. So the ionization enthalpy will be more. So this may be 1600 kilojoules like that. Okay. So what will happen? What is the answer? So when you're comparing IE1 and IE2, so IE1 will be always less than IE2. Okay. So here, which is the correct answer? It is option number A. Okay. E1 is less than E2. Okay. So Madan has answered it correct. Very good. And okay. So option number A. Understood? So whenever you are seeing the ionization energy, so ionization energy of the first electron, okay, as compared to the second, it will be less. Okay. Let us go for the next one. Ionic radii are A, inversely proportional to effective nuclear charge, B, inversely proportional to square of effective nuclear charge, C, directly proportional to effective nuclear charge, D, directly proportional to square of effective nuclear charge. Okay, Madan has answered it as A. So ionic radii. Okay, so radius, when you are discussing about ionic radii, so ionic radii, it is inversely proportional. Okay, so if it is inversely proportional to the effective nuclear charge. Okay, so if you are calculating the radius of an nth orbit, so it will be given as n square into a naught by z. So from this, you can see that radius is directly inversely proportional to effective nuclear charge. So it is option number A. Option number A is the correct answer. Okay, let us go for the next one. Which is the metalloid? A, lead, B, tin, yes, antimony, C, silicon, and D, zinc. Which is a metalloid? What is a metalloid? It has a property in between that of metals and non-metals. Then it is called as a metalloid. So which is a metalloid in this? It is, yes, Madan and Vedvati have answered it right. It is silicon. So silicon is a metalloid. Very good. So let us go for the next one. The element with the outer electronic configuration 3d64s2 is A metalloid, B non-metal, C transition metal, and D noble gas. The element with the outer electronic configuration 3d64s2 is what is that? So if you have 3d64s2 configuration, so what is the this what element, whether it is a metalloid, whether it is a non-metal, whether it is a transition metal or a noble gas. Okay, Madan and Vedvati have answered it as C, transition metal. Okay, so yes, it is a correct answer, transition metal. Okay. So element with the outer electronic configuration when you have 3d64s2, okay, so it is a d block element. Why? The electrons, the last electron, it is in what? It is filled up in the d orbital. Okay, so it is a d block element. And what d block elements? It is also called as the transition element. So option number C is the correct answer. Okay. Okay. Let us go for the next one. Consider the isoelectronic species. Now, before that, what do you mean by isoelectronic species? Yes, isoelectronic species are those which having same number of electrons. So this is a set of isoelectronic species where you have Na plus, Mg plus 2, F minus, and O2 minus. So you have to write the correct order of increasing length, increasing length of their radii, of their radii. Okay. So, okay. Remember that whenever you have negative charge, okay, whenever you have negative charge, okay. So if more negative charge, so you remember, okay, before that, anions, okay, anions are having larger size. Anions will have larger size as compared to cations. Okay, cations will have smaller size. First, you remember this. Okay, when you're comparing anions and cations, anions will have larger size as compared to cations. So this is the first thing you have to keep in mind. Now, what is the second thing? Second thing is that whenever you're comparing anions, okay, more negative charge, more or it is a large size. Okay. And when you're comparing cation, more positive size, positive charge, small size. Okay. Now how you will compare? O2 minus, yes, O2 minus. So O2 minus is what? It will be having the highest. Okay, O2 will have in the highest. Then comes your F minus. Then comes your Na plus. Then comes your Mg plus 2. Okay, now they have told increasing order. Increasing means it will be reverse. So Mg plus 2 will be more than, Mg plus 2 is less than Na plus, increasing order, right? So Na plus is less than F minus and F minus is less than O2 minus. So it is option number which one? O2 minus. Okay. Option number B. Option number B. Yes, Vamshi Krishna, Vedvati, and Madan have answered it as B. Very good. Okay. So remember this. So these criteria, you have to remember these points. Okay. When you have a isoelectronic species. So what do you mean by isoelectronic species? Isoelectronic species are having same number of electrons. Okay. Let us go for the next one. Consider the following statements. The radius of an anion is larger than that of the parent atom. The ionization energy generally increases with increasing atomic number in a period. The electronegativity of elements increases on moving down across the period. So which of the above statement is correct? Yes. Okay, Vedvati and Madan have answered it as C. So when we are comparing these statements, so just now, so we have just seen the radius. So I have just discussed you that the radius of the anion is always larger than that of parent atom. Okay, so option number 1. So this statement is correct. So 1 is the correct statement. The ionization energy increases with increasing atomic number in a period. So when we are discussing about ionization energy, okay, as you are going across the period, what will happen to ionization energy? Okay, so when you are going across the period, what will happen to ionization energy? So as you are going across the period, there will be atomic number increase. So as the atomic number increases, okay, as the atomic number increases, what will happen to the ionization enthalpy? Ionization enthalpy or ionization energy, it also increases. Okay, it increases across the period. And as you go down the group, what will happen to it decreases as you move down the group. So option number, this is wrong. Then last one, electronegativity of a element increases on moving down the group. So, sorry, the second one is correct, right? Because you can see the ionization energy increases with increasing atomic number. Yes, so it is correct. Okay. Now, electronegativity of an element. When we are comparing, what is electronegativity? It is the ability of an element to attract the what attract the this. Now suppose I have a fluorine atom. Okay, so fluorine atom, it is attached to hydrogen, so the capacity, okay, the ability of an electron to attract the shared pair of electron towards itself, electronegativity when we are comparing, so as we are, so what it is said, it is increasing as you move down the group. So the correct factor is that as you go across the period, electronegativity, what happens? It will increase. Okay. And when you go down the group, it decreases. It decreases. So option number, this statement is wrong. So option 1 and 2 are correct. So which is the correct? It is C. Yes, Vedvati and Madan have answered it correct. So option number C is the correct statement. Okay, let us go for the next one. The formation of the oxide ion O2 minus from oxygen atom requires first an exothermic and then an endothermic step as shown below. So the process of formation of O2 minus in gas phase is unfavorable even though O2 minus is isoelectronic with neon. Why? It is due to the fact that A. Oxygen is more electronegative. B. Addition of electron in oxygen results in larger size of the ion. C. Electron repulsion outweighs the stability gained by achieving noble gas configuration. D. O2 minus O minus ions has comparatively smaller size than oxygen atom. Yes. Okay, Madan and Vamshi Krishna has answered it as C. So electron repulsion outweighs the stability gained by achieving noble gas configuration. Okay. Yes, option number C is the correct. So in the first step, what you can see, when the oxygen, when it takes electron, it forms O minus. See the, it is exothermic step. In second, O minus plus it takes one more electron. Okay. So here what it is taking electron gain enthalpy, right? So the electron gain enthalpy here it is positive because it is undergoing an endothermic step. So what is happening? The electron repulsion outweighs what it will see that the stability will be gained by achieving the noble gas configuration. Okay. So when you are comparing the O2 and O minus, so O2 minus is more stable. Okay, because it will what it will take the electron gain. This I it will be noble gas configuration will be more stable in that case. Okay, electron electronic configuration of the four elements A, B, C, and D are given below. Which of the following is the correct order of increasing tendency to gain electron? Yes, electron gain enthalpy. It is the minimum energy required by electron to add an electron to the gaseous atom. Okay, one. A. Madan has answered it as A. So A is what? A is less than C, which is less than B, which is less than D. A is what? 1s2, 2s2, 2p6, Then comes your 1s2, 2s2, 2p6, and then 3s1. Then comes your 1s2, 2s2, and 2p4. Then comes your 1s2, 2s2, and 2p5. So this is the correct order of stability. Okay. The period number in the long form of the periodic table is equal to. So what is the period number in the long form of the periodic table equal to? So it is equal to the first quantum number, that is principal quantum number of element. Okay. So periodic table, the periodic number in the long form of the periodic table, it is equal to nothing but the principal quantum number. It is the first quantum number. Okay. So we have studied the four quantum numbers. So this resembles the first quantum number. Okay. The incorrect statement among the following is, so which is the incorrect statement among the following? The ionization potential of Al is less than the first ionization potential of Mg. The second ionization potential of Mg is greater than second ionization potential of Na. The first ionization potential of Na is less than the first ionization potential of Mg. D. The first ionization potential of Mg is greater than the third ionization potential of Al. Yes, Madan has answered it as B. Kumla has also answered it as B. Shri Krishna has also answered it as B. So when we compare what they have second, the second ionization potential of Mg, okay, is greater than the second ionization potential of Na. So we know that sodium, okay, sodium is the first element here. Sodium, potassium, rubidium, cesium. So here potassium, this comes here boron, beryllium, magnesium, right? So when you compare your sodium and magnesium, i.e., that is the second ionization of Mg, okay, this is lower. Okay, it is lower than that of Na. Why? Because in case of Mg plus, okay, three s electrons are there, and this three electrons is to be removed. While in case of Na plus, okay, in Na plus only one electron is there, right? So and it is already removed. So because of that, it will what it will do? It will be in its stable configuration state. So option number B is the correct answer. Option number B. So in case of Mg, it will be lower, but in case of Na, it will be higher because it will be very difficult to remove the second electron because it is already in its stable noble gas configuration. The valence shell of element A contains D is three electrons, while the valence shell of the element B contains six electrons. If A combines with B, the probable formula of the compound formed will be. Okay, Komala has answered it as C. The valence shell of element A contains three electrons. Okay, and while the valence shell element B contains six electrons. If A combines with B, the probable formula of the compound will be. So A contains three electrons. So it can be three electrons is Ns2 Np1 I can take, and B contains six electrons. So it will be Ns2 Np4. Right. So what they can form? They'll form A2B3 type. Option number C. Yes, Madan and Vamshi Krishna has also answered it correct. Okay, so option number C is the correct answer. Okay, Na plus Mg plus 2, Al plus 3, and Si4 plus are isoelectronic. The order of their ionic sizes is. So these are all positive charges. So we know that cations are having smaller size, and if their positive charge is more, then the size will be smaller. So Si plus 4. So Na plus will be more than your Na will be more than Al plus 3. It will be more than Si plus 4. So option number D. Sorry, option number C. Option number C. Okay, so you can see option number C. Right. Option number C. Yes. Shri Krishna has answered it correct. Option number C is the correct answer. Okay. Let us go for the next one. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number of the element which is just below the above element in the periodic table? So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So the atomic number is what? The atomic number of the given element is 15. Right. So what they have asked, what is the atomic number of the element is 15, which is just below the above element is. So you have to tell which element it is. So here, now this 15th elements, it belongs to which group? It will belong to fifth group. Okay. So atomic number of element below the above element will be 15 plus 18. It will be 33. Yes, Vamshi Krishna and Kumala has answered it correct. So atomic number of the given element is 15. Okay. And it belongs to fifth group. So 15 plus 18. Okay. So it will be 33. Option number A. Which one of the following ionic species has the greatest proton affinity to form stable compound? So when you see the ionic species, okay, and their proton affinity, so nitrogen family will have more affinity than your oxygen family and then your halogens. Okay. So option number A. Yes, Vamshi Krishna and Komal have answered it correct. So proton affinity, what happens as you move across the period, it goes on decreasing. So nitrogen family will be having more. Okay, because as you're moving from left to right, the charge increases and therefore the affinity decreases. So nitrogen family will have more affinity than oxygen and then your halogen family. Okay. An element M has an atomic number 9 and atomic mass 17. Its ion will be represented by. So how will the ion represented? So M, atomic number 9, and this is 17. So how will be its ion represented? So, so atomic number 9 is of a fluorine. So it is a halogen. Okay, it is a halogen, and you can see that it has one electron less. Right, it has one electron less. So because it should have 18 electrons, so it is having one electron less here. So it is represented as M minus ion. Okay. So how is the fluorine ion represented? It is represented as M minus. Yes, option number C. So it is C option. Okay. The elements with atomic number 9, 17, 35, 53, and 85 belong to. So to which this family it belongs to? 9. 9, they belong to, it is a fluorine. Okay. Then 35 is chlorine. Remember, so this is what it belongs to, halogen. Option number C. Okay, it belongs to halogen. Option number C. Okay. The radii of F minus, O2 minus, and O are in the order of. So if we know that, again O2 minus will be greater than F minus, will be greater than fluorine and oxygen. Now when you are comparing oxygen and fluorine, okay, so your oxygen is having 8, okay, and 16. Fluorine is having 9 and 18. So oxygen, okay, and then fluorine. So atomic radii of the atom, okay, depends upon the relative charge. Okay, and therefore the atomic radii will be in this manner. So option number A, yes, Madan and Vamshi Krishna has answered it correct. Okay, so option number A. So which of the following elements does not belong to first transition series? So which of the elements does not belong to first transition series? Fe, Fe belongs to transition series, palladium belongs, copper belongs, Ag. Okay, it does not belong. So option number C. Is it? Option number C is the answer. It does not belong to first transition series. Yes, Madan has answered it correct. Okay. Which transition involves maximum amount of energy? So which transition more energy? So as we have told, ionization energy is what? Ionization energy, what is happening? It is the amount of energy required, minimum amount of energy required to remove the electron from an isolated gaseous atom. So as you are removing the electron, okay, subsequently, as you are removing, the energy required will be more and more. So when you are removing E1, E1 will be less than E2. Okay, E2 will be less than E3. E3 will be less than E4. Okay, so like this. So here you can see subsequently, okay, in D. So here the electron is removed from the M2 plus. Okay, so already the two electrons are removed, so it is D. Yes, D is the correct answer. So Komala, Vamshi, Krishna, and Madan have answered it right. Very good. Okay, so like this, you have to see the reaction and then give the answer. Okay. So by this, we have completed. Yes, Jyoti Natikar has also answered. Very good. Fine. So by this, we have completed the MCQs on the chapter classification of elements and periodic properties. Okay. So any doubts up to your? Yes. Any doubts? This completes our chapter classification of elements and periodic property. So any doubts in this session? So, so after this, okay, you'll be